Welcome to today's Explainer. Okay, we're jumping right into some seriously fascinating research today. We're looking at an incredible study out of Jahandharnagar University that basically trains machine learning algorithms to act as, well, medical detectives. And their target? A global killer. It's a brilliant look at how data science is stepping up to tackle one of the most critical health emergencies we face today. Just to put this all into perspective, stroke is the second leading cause of mortality globally. I mean, someone passes away from a stroke literally every 4 minutes. But here's the crucial point, and really the whole reason this research is an absolute game changer. Up to 80% of strokes are entirely preventable. 80%! That is, if we can just detect the risk early enough. You see, the clues are usually right there, just kind of hiding in a patient's medical profile, long before the actual emergency strikes. To see exactly how AI is shifting healthcare from reactive to proactive, here's our roadmap for today. First, the silent killer. Second, the clinical clues. Third, training AI detectives. Fourth, profiling risk factors. And finally, the final verdict. Let's get into it.
Section 1. The silent killer. Understanding the enemy. We've got to understand our suspect first.
So, what exactly does a stroke do to the human body? Well, there are two primary types of this medical emergency. Ischemic strokes, which are the most common ones you'll hear about, happen when a blood clot develops, usually in the heart, and travels up to block the narrow arteries of the brain. On the flip side, we have hemorrhagic strokes. This is when an artery in the brain actually ruptures or leaks, just spilling blood right into the surrounding tissue. Both of these completely disrupt normal brain functions and cause permanent, devastating damage. It's why early prediction is quite literally a matter of life and death.
Currently, we rely super heavily on human observation to catch a stroke in action. As highlighted in the study by neurologists like Dr. Chaudhary, doctors use the Be Fast acronym to identify a stroke as it's happening: balance loss, eyes having vision issues, facial asymmetry, arm weakness, and slurred speech. Basically, if you see these, it's time to act immediately. But, this is entirely reactive. The ultimate goal of our AI detectives is to spot the underlying danger way before these terrifying physical symptoms ever appear.
Moving on to Section 2, the clinical clues. It's time to build our suspect profile.
Okay, so to train our AI, the researchers first needed a massive database of clinical clues, utilizing over 5,100 patient records. But the baseline data imbalance in this study is wild. Over 95% of the patients in the dataset had absolutely no history of stroke, while less than 5% actually had one. Teaching an AI to find a stroke profile in this raw data, it's literally like finding a needle in a massive haystack. I mean, if you feed this directly to a basic machine learning model, the model will just lazily guess no stroke every single time and still walk away looking like it's 95% accurate.
Which brings us to Section 3, training AI detectives, the methodology.
So how in the world do we train these algorithms to recognize such a rare, deadly event without them getting completely confused by the overwhelming amount of healthy patient data? Well, the researchers had to build a really rigorous pre-processing pipeline. Step 1, loading those 5,110 records. But Step 2 is where the real magic happens. They used a brilliant, highly inventive technique called SMOTE, which stands for Synthetic Minority Oversampling Technique. Basically, it analyzes that tiny 5% of actual stroke patients and artificially generates new statistically similar samples to balance out the data. It forces the AI to properly learn what a stroke patient's profile looks like, rather than just ignoring them as statistical blips. After that, they isolated the most critical features and set up 10 different machine learning classifiers to battle it out.
The architecture they use to achieve this is brilliant. They start with raw datasets, and the data moves through a pre-processing block where they handle missing data, normalize the variables, and like we just talked about, fix that massive data imbalance. From there, the refined, cleaned-up data is fed straight into 10 distinct AI models, ranging from random forests to support vector machines, so the researchers can evaluate and compare their performance side by side.
Now for Section 4, profiling risk factors, the clues that matter.
Once those AI detectives analyzed the pre-processed data, they began to isolate the primary risk factors, basically zeroing in on the prime suspects. The first major clue? Well, it's something none of us can control: time. When comparing the overall age distribution of patients with actual stroke occurrences, you find the risk isn't evenly spread out at all. The data shows that the likelihood of a stroke dramatically spikes once a patient passes the age of 60. The models immediately flagged advanced age as the most obvious amplifier of risk.
But of course, age alone isn't the whole story here.
The AI models systematically proved that the presence of underlying conditions, specifically hypertension, heart disease, and high average glucose levels, act as massive multipliers for a patient's overall stroke risk. And honestly, this is exactly why this explainer is so important. These are modifiable, trackable factors. If an algorithm can weigh these specific data points against your age and BMI, it can sound the alarm while you still have plenty of time to make real lifestyle changes.
And finally, Section 5. The final verdict, grading the AI detectives.
We've got the data, we've got the pipeline, and we know the risk factors. So the million-dollar question is, out of all 10 machine learning models tested, which algorithmic detective actually performed the absolute best at profiling our killer? The researchers recognized early on that every single algorithm brings its own unique strengths and weaknesses to processing complex medical data. For instance, a random forest classifier is highly efficient, but, it can be pretty slow to output predictions. A decision tree, incredibly fast but prone to memory issues when you scale it up. They couldn't just assume one was better, they had to grade them ruthlessly.
And here's the thing about medicine. You can't just grade an AI based on simple accuracy. You have to use what's called a confusion matrix. Why? Well, because a false negative, meaning the AI tells a patient they are perfectly fine when a stroke is actually imminent, is quite literally a fatal mistake. So the researchers had to evaluate true positives, true negatives, and heavily penalize any false negatives.
When evaluating the predictions by age, one model in particular, the K-nearest neighbors model, completely failed to find true positives. Just a massive blind spot. And this highlights perfectly why rigorous testing of multiple models is so essential. Because if a hospital just blindly trusted that specific algorithm, man, patients in serious danger would just slip right through the cracks.
But out of the pack, a clear winner definitely emerged. Ultimately, the study concluded that advanced boosting classifiers, specifically models like XGBoost, LightGBM, and CatBoost, dramatically outperformed the rest of the field. These ensemble methods work by combining multiple weak prediction models to create one massive, highly accurate supermodel. And in this study, they achieved a staggering 97% accuracy in predicting stroke prognosis, all based on routine clinical data.
Really think about what that means for a second. We started this explainer noting that 80% of strokes are completely preventable with early detection. Now, we have an AI model that can process routine physical exam data, stuff like your age, your marital status, your blood pressure, your glucose levels, and predict a stroke with 97% accuracy. With preventative models this sophisticated, it completely shifts how we view the entire future of public health. It definitely leaves us to wonder, with the data and the math already proven, how long will it be until this life-saving AI detective becomes just a standard automated part of your annual checkup?